Okay, so as I said, we're going to pick up what we did yesterday. Look at this lesson 10-2. We're going to look at this one, then we'll look at the fractions.
10-2 review.
Yeah. Okay. So when we have two radicals, what was the first thing I would suggest you do yesterday?
Combine them.
Combine them, right? Now, keep in mind, outside pieces are going to multiply with outside pieces, right?
Yeah.
So 7 times 3? 21. And then we're going to multiply radical with radical. So 5x times 20x to the fifth.
100x to the 6th.
Okay, 5 times 20 is 100. And then x to the invisible 1 times x to the fifth. We add the exponents, x to the sixth. Okay. That 21 out front is going to carry down as 21. What do you know about the square root of 100?
It's 10.
It's 10, right? It's on our blue paper, which means it's a perfect square.
Yeah.
So the square root of 100 is 10. What about the square root of x to the sixth? What did we do with exponents?
Well, it's an even number.
Uh-huh.
So you get half of it, so it's going to be x to the third.
Right. An exponent, you just divide it by 2. Since 6 divides by 2 nicely, that becomes x to the third. All my square roots
Yes.
disappeared, right? They're gone. So just multiply the remaining pieces back together for an answer.
210x to the third.
Okay.
Yes.
21 times 10 is 210.
X3.
Tag on x to the third. Okay. So that at least jives your brain a little bit on what we were doing yesterday, right?
Yeah.
A little bit.
Okay. So, this is the part 2 page. This is the fractions. I told you pretty much last night you could skip everything that involved fractions. I think there might have been one that had a fraction within it that you could maybe do, but other than that, skip that. So, square root of 144 over 9. The big thing right here is we're not allowed to have a fraction under the radical. And each problem is going to be a little bit different, of course. The first thing I always suggest you do, well, there's 2 different ways we can do this. Let me reverse this. Do you guys see anything? Fraction under the square root.
It's improper fraction.
It's the square root of it. No.
You might be on the right track.
They're perfect squares. Each of them.
Or 144 and 9? Is 144 on my blue paper?
Yeah.
You have to go to the next column, right? 144 is a perfect square.
My calculator is over, so I said no.
Ah, is 9 a perfect square? That's the easy one. So, one option is to just take the square roots. What is the square root of 144? 12. What is the square root of 9? 3. As always, if you can simplify, you go one step farther. Can I simplify 12 over 3?
Oh, yeah.
12 divided by 3 is 4. So your answer to this problem is
4.
4.
That was cool.
Oh.
Easy.
That's a lot easier.
Listen, we have different levels. Are they all going to be this easy? No, but you know. Now, here's my other thought on this one. And there are certain times that it's important that you take this other way instead. Can you divide if you go back to the original problem for a moment, can you divide 144 by 9?
Yeah, it's like 16.
Okay, so if we do 144 divided by 9, that is 16. Now notice, have I taken the square root yet? No. So another way to think about this is if you can divide numerator and denominator, try it. It divided nicely, didn't it? It gave me a nice, neat whole number. My fraction's gone. What do we know about the square root of 16?
It's 4.
It's 4.
And that's your answer.
Hey, guess what? That matches my answer, doesn't it? Both are good ways to do this. It just depends on the problem as to there are times where it is important to divide before you square root. But in this problem, it didn't matter. Okay. Moving along. Shall we try the next one?
Sure.
Yeah. Okay.
Square root of 36a over 4a cubed.
36
Divided by 4. And that's 9.
Okay. So both top and bottom are going to divide by 4 then, essentially, right?
Yes.
Now, what about the a's?
Subtract, right?
Yeah, it is, but I don't really want to come up with, well,
A to the A squared. I don't know.
Okay, well, I'm trying to go with what you guys are doing here.
Well,
It's not the normal way I do it, though, but no, I'm not against it. Okay, so you're telling me 36 divided by 4 is 9. A, and that's a to the first, right?
Yeah.
Divided by a to the third. If you subtract those exponents, 1 minus 3 makes it a negative 2. Okay. Now, first of all, that took us to negative exponents, which that's fine. But we can't leave it with a negative exponent.
We'll go 1 over.
Okay, so we're actually going to go back to a fraction for a moment, but that's okay. What has the negative exponent that needs to move to the bottom?
A squared.
A squared. So a to the negative second moves to the bottom and becomes a to the positive second. What about this 9? Does it have a negative exponent?
No.
No. So does 9 need to move to the denominator?
Yes.
No.
No. It's going to stay on top.
My brain plays with numerators, so I said yeah.
Okay? So, now we have 9 over a squared. Can you take the square root of 9?
Yeah, it's 3.
Square root of 9 is 3. Can you take the square root of a to the second?
No. Well,
We can do A1 with the division. That'd be weird, so we just do A.
How do we take the square root of an exponent? That was on the
Okay.
previous page.
you divide it by 2.
You divide it by 2.
So it's going to be just A.
Does 2 divide by 2?
Yeah.
It does. So it's going to be a to the first, which is just a. So I can write this answer as
3A.
3 over a.
Does it not normally turn out a fraction when you do it?
No, it does. This is the same answer I have here. Just different way of getting there. And what I'm trying to decide is how important it is to show my way based on what we just did here. Because there's nothing wrong with what we did. It's all legitimate. It's just not, there's not always just one way to get to an answer. We took a different way than what I was expecting. But I also sometimes like to go with, okay, what do you guys see? I'll just show real quick a little that,
Was the way you were expecting?
okay, so 36 divides by 4, and that, that was pretty easy. The problem we run into is a doesn't divide by a cubed in that, it gave us that negative exponent. So what I tend to do is I tend to say, okay, what do my numerator and denominator both divide by? 36 and 4 both divide by 4. And how many a's do they both have in common? They each have at least one a. So what I do when I do this is I divide top and bottom by 4a. And so then, on top, 36a divided by 4a. 36 divided by 4 is 9, and the a's will cancel. On bottom, 4a cubed divided by 4a.
4a squared. Wait, no.
It should be a squared.
A squared.
The 4's cancel. A cubed divided by a is a squared, and isn't that where we ended up? Okay? So I just kind of showed that because might that be important for a different problem? It might. Might you always be able to go this way? You might. I'm not 100% sure there. Okay? Okay, so as we looked at these first two, we were able to divide, right? 144 divided by 9 gave me 16, or they were perfect squares. Here, we were kind of able to divide to the point where we got them to be perfect squares. Okay, next one. Square root of 25y cubed divided by z squared. I'm always going to ask, is there anything I can divide or reduce first? I mean, we'll talk about taking some square roots, but in terms of just dividing or reducing the fraction, there's only one whole number, 25. There's no other numbers to reduce that with. There's a one y piece, y cubed, no other y's to simplify with. But there's a z piece, no other z's to simplify with. So we can't do any of this up here where we're simplifying it. So this is where we start looking for perfect squares. Okay? And I think what I'm going to do is I'm going to break this up into pieces. Am I going to be able to take the square root of 25?
Oh, yeah, that's fine.
Okay, now I'm going to leave it as 25, so I'm going to leave this under the radical right now, okay? I'm going to take this in pieces. Am I going to be able to take the square root of y cubed?
Yeah. Well, it'll just end up being y.
Well,
And
if it's y to the third, in order to take the square root, we have to be able to take that exponent and divide by
2.
2.
Yeah, but don't you, like, subtract until it's an even number?
Okay, so here's the deal. Does 3 divide by 2 itself? No. So what's the closest number below 3 that does, which is, I think, what you're talking about? So there's going to be a y squared that we can take the square root of, but then there's also a leftover y to the first. And this is what I'm trying to do right now, is break this into any perfect square pieces and any, I would call this y to the first a leftover piece. We couldn't take the square root of it. Am I going to be able to take the square root of z squared? Does my exponent divide by 2?
Yeah.
2 divides by 2, so I'm just going to leave it as z squared. Because as I said, I'm not taking any square roots in that step. I was just kind of doing the work. Basically, I had to do the work on the y's. Now, we have it all set up the best we can. So, okay, there's my fraction bar. Square root of 25. 5. And that means that 5 is outside the radical, right? Square root of y to the second. Y to the first, right? 2 divided by 2 is 1. So y to the first, or y. Square root of y to the first. You can't, so we're going to leave that y under the square root. So here's the deal. Y to the second, we took the square root and got y. That's outside the radical. This y here was our leftover piece. We can't take the square root, so it stays in the radical under the square root. Okay, anytime you can't take the square root of anything, it has to stay under the radical. Square root of z to the second.
Z.
Does my exponent divide by 2? 2 divided by 2 is 1, so it becomes z to the first, or in other words, z. Okay. Did I get all of my perfect squares out from under the radical? Okay. Did I get any radicals out of my denominator? Do I have any radicals left in the bottom of my fraction? No, so that's good. Do I have any fractions left under my square root sign?
No.
No. So this is good. This is a final answer. It may not be pretty, but it's an answer. I think it says these answers are going to be pretty. Okay. Next example.
Yes.
Okay, we went from loud to blowing to
Yeah, it's
it turned off. It got really loud right before it turned off. Because Jacob, you kind of looked at me like, oh my gosh, that's getting loud. And now I feel like I'm going to be yelling when I talk at normal level. Because my normal level is yelling over the fan, I feel like.
Yeah.
Okay.
Now we'll hear the clip from the wall.
Maybe that's why I haven't heard them as much lately. When the air is blowing. Okay. Square root of 2 over square root of 3.
Okay.
What does okay mean?
Well, it's a fraction, but there are square roots on both sides, and neither of them are perfect squares.
Okay. So we have a problem, is what you're saying.
Yeah.
Okay. So there's no perfect squares we can't take the square root of 2 or 3. There's no perfect squares we can, like yesterday how we were trying to break it up into pieces. There's nothing to do there because it's just 2 and 3.
Mm-hmm.
So this is where we start a technique called rationalizing the denominator. Okay, so in some of your homework, you might be asked to rationalize the denominator, and that's what we're doing here. Rationalize the denominator. Okay, so one of our big rules is we're not allowed to leave a square root sign in the bottom.
Yeah.
Right now we have a square root sign in the bottom, and we can't get rid of it. So to rationalize the denominator, we need to get rid of the square root in the denominator, so we multiply the denominator by itself. When there is just one term, we multiply the square root by itself. So in the denominator, it is square root of 3. So we're going to multiply by
3.
Square root of 3. What I do to the denominator, we do to the numerator. So the denominator I multiplied by square root of 3. What am I going to multiply the numerator by then?
2.
Nope.
3. Sorry.
3. It's not that, I know, that's a mistake I was expecting though.
Yeah.
And it's not that we're multiplying by the square root of itself. I mean, it is the square root of itself, but it's specifically, we're multiplying by the square root of the number 3. That's what we do in the denominator, so we do the same thing to the numerator. In the numerator, what is the square root of 2 times the square root of 3?
The square root of 6.
Square root of 6, good. In the denominator, what is the square root of 3
9.
times the square root of 3?
Square root of 9.
Square root of 9. But what do you know about the square root of 9?
It's a perfect one.
Square root of 9 is
3.
3. Square root of 6 is still
Square root of 6.
square root of 6. Your final answer?
Is the square root of 6 over 3.
Square root of 6 over 3. Now, why am I not dividing this?
Because
It would be a decimal. No, it wouldn't, but it'd just be a whole number.
because the 6 is in a square root and the 3 is just by itself.
Okay, yeah. I mean, yes, 6 divides by 3, but this is the square root of 6. And if you did the square root of 6 divided by 3, you're going to get some nasty decimal in the calculator. So my point in making this is that if you have a number under a square root and a number not under your square root, you cannot divide those. Just like you can't multiply them. They have to either be both under the square root or both outside of the square root. Okay?
Mhm.
Okay. 2 more to look at?
Sure.
Although Mikayla's up to something here.
Square root of 6 divided by 3 is 1.41421352.
Lovely irrational number.
Horrible.
I'm going to move on to my next page because I think, yep, I already blew the next 2 up on the next page. Okay. Square root of 5 over square root of 18m.
Okay. Do the multiply by 18 and maybe? I don't know.
No, it's not wrong. It's just a little bit bigger than what we need to do.
Okay.
So, and this is where, again, do I want to take you that, because we could go your way, we'd just be taking the longer route.
Okay, well, let's do the shorter route.
And I kind of do want to do the shorter route here. Okay, so first of all, the question I'm going to ask, not that it matters, but I'm always going to ask it. Does the fraction 5 over 18m reduce any?
No.
Okay, so always check that first. And I don't know, you may have checked that on your own already. But what I would do before multiplying by square root of 18m is I would simplify this square root first. Okay, so 5. Let's start on top first. Does 5 have any perfect squares in it?
No.
No, 5 is just 5 times 1. That's 5. What about 18? Does 18
2.
have any perfect squares in it?
No.
So 18 doesn't divide by any of my perfect squares here?
Oh.
Yeah.
324.
No, you're going the wrong way here.
I don't know.
Okay, so this goes back to what we did yesterday. Does 18 divide by any of these little numbers over here? Does 18 divide by 16?
Oh, jeez. Okay.
18 doesn't divide by 16
Divides by 9.
because we get a decimal, and 18 doesn't divide by 4 because we get a decimal, but 18 divides by 9.
Yep.
You remember doing this yesterday?
Yeah.
We just haven't really done it yet today, have we?
Yeah.
So that's what I'm going to do here is we're going to break this up. So my numerator is staying square root of 5. Square root of 18 breaks into, what did you say 18 was going to be? 9 times 2. So square root of 9 times square root of 2. And then we also have the square root of m, which I can't break the m up. So now, on top we still have square root of 5. Denominator, square root of 9
3.
is 3. Can I take the square root of 2?
No.
Not nicely, right? Can I take the square root of m?
No.
No. So I'm going to put them back together in a radical and say square root of 2m. Now, I did that work. I still have a radical in the denominator. But my radical in the denominator is smaller. So now we're ready to rationalize. So let me bring this radical over here. Square root of 5 over 3 square root of 2m. What is the radical I need to get rid of in the denominator?
Two, and I don't know.
Put it all together, the whole thing.
2m.
The square root of 2m, yes?
Yeah.
I have the square root of 2m, and I need to get rid of the square root of 2m. How do I get rid of a square root of 2m?
Multiply by 2m, square root of 2m.
We're going to multiply by itself, so we're going to multiply by square root of 2m. What we do to the denominator?
Due to the numerator.
Due to the numerator. So I'm going to multiply my numerator by square root of 2m.
Square root of 10m.
Okay, on top, square root of 5 times square root of 2m is square root of 10m. Denominator.
3 times square root of 4m squared.
Okay, the 3 stays out front. Square root of 2m times square root of 2m is going to be 2 times 2 is 4. M times m, m squared. Now, what's the whole point of what we need to do in the denominator here?
Well, now you can do this.
Yeah. Still square root of 10m on top. There's still a 3 on bottom. What is the square root of 4m squared?
2m.
2m. Are you noticing the trick here? When you do square root of 2m times square root of 2m, it eventually just becomes 2m. A square root times itself will always just be whatever's under that square root.
Mm-hmm.
Okay.
This one would be great.
In the denominator, what is 3 times 2m?
6m.
6m.
And that's your answer.
Why am I not reducing the 10 and 6 or the m's?
Because we're going to be great.
Because one's on square root and one's on.
Okay. Square root on top, not square root on bottom. And the blowing's back.
I thought that was raining though.
And
That's
this-
why I turned around so quickly. I was like, oh gosh. But it's not going to be that cold out though.
Okay. One last example. Square root of 7x over 3. Can 7x and 3 divide?
No.
Nope, darn it.
Should be like 3.5.
Nah, you're thinking of 7 halves.
I don't know.
7 thirds is going to be 2.3, I think. So, okay. So, if it helps, this is under 1 square root, and I don't know how much I've really shown this, but realize the square root of 7x over 3 can also be thought of as the square root of 7x over the square root of 3. 7 and 3 don't reduce. Are there any perfect squares here?
No.
Nope, 7 and 3 are just prime numbers, no perfect squares. So what do I do? Am I done?
No.
No, because I have a square root in the denominator.
Yeah.
How do we get rid of that square root of 3?
You are multiplying. Yeah.
Multiplying by what?
Multiply by 3.
Multiply by square root of 3?
Yes.
Okay, so in order to get rid of a single square root on the bottom, you multiply by that same square root. So we're going to multiply by square root of 3. If I multiply the bottom of the fraction by square root of 3,
It's going to be square root of 6.
you're going to multiply the top of the fraction by square root of 3.
Yeah.
Square root of 7x times square root of 3.
Sorry, I keep yawning.
Square root of 21x. Square root of 3 times square root of 3.
Yeah, no.
Square root of 9.
I don't know why I argued myself so much on this.
I was trying to let you get it.
What do we know about the square root of 9?
It's 3.
It's 3. So we can give our answer as
21x over 3. Or
square root of 21x over 3. And again, I'm not dividing the 21 3 because 21's under a radical, 3's not.
I don't know.
Okay, your homework is to try and finish lesson 10-2 in Math Excel. And I'm going to say bring back your questions tomorrow. Okay? So with the fractions, there may be some you get stuck on. We'll talk about them tomorrow.